Welcome to the Campus Energy and Sustainability Podcast. In each episode, we'll talk with leading campus professionals, thought leaders, engineers, and innovators addressing the unique challenges and opportunities facing higher ed and corporate campuses. Our discussions will range from energy conservation and efficiency to planning and finance, from building science to social science, from energy systems to food systems. We hope you're ready to learn, share, and ultimately accelerate your institution toward solutions. I'm your host, Dave Karlsgodt. I'm a principal at Fovea, an energy, carbon, and business planning firm. In this episode, you'll hear my interview with municipal water system expert Melinda Friedman. Melinda is the founder and president of Confluence Engineering Group, LLC, based in Seattle, Washington. She has more than 2 decades of experience providing services around source and distribution system water quality, regulatory compliance, comprehensive planning, and optimized treatment practices. During this interview, Melinda helps to unpack what went wrong during the recent water distribution crisis in Flint, Michigan. She also lays out some of the friction she runs into between the sometimes competing goals of water conservation and water quality and safety. While Melinda is primarily focused on municipal water systems rather than campuses, I hope you'll find that she brings an important perspective to some of the central issues all campus facilities and sustainability departments need to grapple with. With that introduction, here is my May 12th, 2017 interview with Melinda Friedman. Melinda, it's great to have you on the Campus Energy and Sustainability Podcast today.
Thank you for having me. It's great to be here.
Well, Melinda, the genesis of this episode was based on a conversation you and I had about, 5 months ago now? And at the time, I knew you had been working in Flint, Michigan to help address the crisis they were having with their water distribution system. And that, at the time, was still very much in the headlines. There were lots of media reports of, truckloads of water bottles and irate parents worried about lead poisoning, and definitely a political firestorm going on in that area. And I'm sure we'll talk about a few of those topics today. But what struck me from that conversation was that you were the first person to describe to me technically what had happened there. You basically had to describe how a municipal water system worked in order to explain to me what had gone wrong in Flint. So perhaps you can start there and give our listeners a technical overview of what actually happened in Flint as an expert in the water field, and then we can take it from there.
Sure. So Flint, Michigan purchases 100% of their water supply from Detroit Water and Sewer. That water is treated from Lake Huron by Detroit and then sent through pipelines to Flint and many other municipalities around Michigan. Due to budgetary problems and financial crisis in Flint that were long in the making, they wanted to find a less expensive water supply that they could have more control over. So along with other municipalities, they wanted to build a pipeline and bring Lake Huron water, which is the same water treated by Detroit, but bring it through a different pipeline directly to Flint and to Genesee County and treat it themselves and distribute it. Now, that's a multi-year process, and in the meantime, an emergency manager was hired in Flint due to bankruptcy and financial problems to help manage the finances of the city. And since the pipeline was going to take many years to be built, and due to many political problems with Detroit, they were rapidly cut off from the Detroit supply, and the pipeline was not finished, so they needed an interim supply of water. So naturally, they went to the Flint River as an interim supply. The Flint River had served the city of Flint for many, many years prior to the 1960s. There is a treatment plant there that has been upgraded as recently as 2000. It's got some advanced treatment processes. And in fact, the city of Flint operates that plant 20 days a year as a designated emergency backup supply. So this was not a rogue treatment system that no one had ever used. This was a designated emergency supply. But what happened was, because of the rapid cutoff from Detroit, the pipeline not being built, they had to quickly go to the Flint supply. And honestly, because it hadn't been used as a full-time supply in many years, the operators and folks were not quite able to control the water quality coming out of the treatment plant to the degree that they should have. So this caused a lot of changes in chemistry going out into the distribution system. One of the key issues with switching to the Flint River was the lack of use of a corrosion control chemical that's in the Detroit water called orthophosphates. And orthophosphates create a film on the pipes on all the miles and miles of pipes to prevent metals from leaching into the water. The Flint River has a different characteristics, and the idea was to use a different process called pH alkalinity adjustment to prevent the leaching and not add the orthophosphates. And that turned out to be a very big mistake because the lack of orthophosphates is what caused all the metals to come off of the pipes into the drinking water.
So the metal was already in the pipes and it had been in the pipes. It didn't come from the water itself.
That is correct. The metals, the Flint distribution system having been built over the last 100 years, 94% of the pipes in the entire system going from the treatment plant to the homes are made of old unlined cast iron pipes, and those are filled with bumps and stalactites and stalagmites, similar to like what you'd see in a cave. We call them tubercles in the drinking water industry. And then because of the time that of homes and the cities were built, at the time, lead was used as a common piping material, as a common service line material to pipe the water from the distribution system main to the home. And lead was used because it's a flexible, bendable material. The elevation of the street may not be the exact same as where you want to tap into your home, and you could actually sort of bend the pipe a little bit. And it was a convenient use, and people didn't understand, 50, 80 years ago, the potential health effects associated with lead. So Flint and many cities around the nation have thousands, hundreds of thousands. It's actually estimated there's probably between 6 and 7 million lead service lines around the nation right now, piping water into our homes.
But because they had used this corrosion control material, there was basically a biofilm covering the pipes. Is that what you're saying?
Yeah, it's not there's biofilm everywhere, but the corrosion control, the orthophosphates, creates a film, a phosphate-based film that keeps the metal more stable on the pipe surface and prevents it from leaching into the water and being carried to the customer. So when you took the orthophosphate away, the pipes had to re-equilibrate. They had to react to this change in chemistry. That was coupled with, I would say, lack of control of the pH and alkalinity coming out of the Flint plant at the time, which might have offset some of that metals release, but that was a secondary problem that occurred with the change.
Got it. And so when the public found out about this, how did that further aggravate the problem?
Yeah, so it started with discolored water. All the iron coming off of the pipes. That was the first indication, and the water that was coming into the homes did not smell good because of everything coming off of the pipes. People assumed that was because it's Flint River water. Flint River water, which runs through the city, they thought does not smell good. It has, discharges, industrial discharges, and other contaminants in the river water. So people naturally thought, and this is a very common misperception, that it's a source water problem. Everything that was at the tap that was so, actually disgusting, the discolored water, the smell, all of that was all stuff coming off of the pipes. That is accumulated. We call them legacy deposits. They are accumulated on all pipes everywhere.
Got it. So even though we're here in Seattle and we get water right out of the Cedar River, which is basically a protected area, you can't even go hiking there. And I always, have this vision of this pristine water that we get to drink, but maybe I shouldn't feel so comfortable in that thought.
Well, the Seattle, we have a fabulous water source here between the Cedar River and the Tolt. You're right; these are protected watersheds. This is basically snow melt, very high quality water that only requires minimal treatment. However, our pipes, we have a lot of unlined cast iron piping traveling for miles and miles here as well. One good thing, though, is in the Pacific Northwest, because of the time that our cities were built here, lead was not really used as commonly. So we really don't have lead surface lines here in Seattle. And in the Pacific Northwest, they're just very uncommon. There are little stretches of pipe called lead goosenecks or lead pigtails that might connect your copper service line or your galvanized service line to the water main, but very uncommon to have huge lead service lines. But because we do have unlined cast iron pipe, and people might have galvanized piping, you might see discolored water coming out of your tap occasionally. And that's just due to reaction of the water with the materials on the pipe.
Got it. Okay. Well, so back to Flint, it sounded like after people did figure out, the water started smelling and changing colors, then people obviously stopped using the water. And how did that further aggravate the issue?
Yeah, so a couple of issues there. It delayed the remedy to the problem more significantly because the way they solved the problem was to switch back to Detroit water, right? Just stop treating it from the Flint plant, go back to the original water where we knew the chemistry would be stabilized with the pipes. But by that time, no one would use the water. So we couldn't draw the fresher, properly treated water into homes and get that. We have to have the orthophosphate. These chemicals have to react with all of the piping surface, every nook and cranny, every bend out your tap. And if nobody's using the water, we can't draw these now properly treated water back into the homes to get the chemical reactions back the way we want them. Another significant problem with Flint, which is not necessarily unique to Flint, but maybe more exacerbated in Flint, is that city and the entire infrastructure for the city was constructed back in the heyday and for a population of its peak of about 300,000 to 400,000 people. Even before the disaster, with the leaving of the General Motors and the decline in auto manufacturing in this country, the population in Flint is down to about 90,000 people. So you think about the size of the pipes and the infrastructure that was built is now, at about a third of its capacity is being used. That creates much longer stagnation times, takes longer for water to move through the system, more reaction time with the pipe walls, and more difficulty in maintaining the chemical conditions we want to get to the tap.
So, Melinda, it's been a while since I've heard anything about Flint in the news. I know you've made some trips out there recently, but what's going on there now?
Well, basically, since October of 2015, they switched back to Detroit water. It's now under a different agency called the Great Lakes Water Authority, but it's the exact same water coming out of Detroit. So the chemistry has greatly stabilized, but that has been due to a lot of flowing water, opening hydrants all around the city to get water moving, getting people to use the water. In May of 2016, they did a whole campaign called Flush for Flint, where they had homeowners open their taps and flush for, I think it was a couple hours a day, just to be pulling water through their homes, as we said, to get these important corrosion chemicals and disinfectant residual out through the pipes into the homes. So with the stabilizing chemistry and improving water flow patterns and we're trying to reduce water age, the chemistry is stabilized and the water quality has improved tremendously. All data show that all data that are being collected according to Safe Drinking Water Act standards show that the water is equal to or similar to or even better in some cases, believe it or not, than other cities in the nation. Now, of course, this increased flow, increased demand, flushing, opening hydrants flies in the face of probably what your listeners are most interested in, which is sustainability and conservation. And that sort of gets to the heart of maybe where there's some, conflict between some public health and conservation goals.
No, absolutely. I remember in our conversation the first time thinking about how much at odds what you're doing is. I mean, I know you as somebody personally being somebody who's very interested in conservation generally. I go to these conferences and there's whole tracks on topics around conservation, low flow toilets and trying to get landscape designs that don't require irrigation and all these things. And that's exactly the opposite of what you're talking about. If you want safety, it sounds like you need flow. And if you want conservation, you need not flow. So what do we do about that?
Well, yes, that's definitely a challenge and a very interesting one and probably very inspiring one for many professionals. I know in the drinking water world, of course, my direct area of expertise is the stability of pipe materials, of biofilm, of metals from the treatment plant to the customer's tap. But there are many other people that are working tirelessly on trying to combine these mutual goals of sustainability and public health. And I know the industry is working towards, there's programs that utilities can participate in called One Water, where we're thinking more holistically about the water cycle and trying to understand impacts and change behaviors. I think that one very interesting thing for your readers your listeners to understand is the impacts of conservation may not always be what they seem. Lower use is good in many ways because, maybe there's less production at a water treatment plant means less pumping, less chemicals added. You might think that, but that's actually not always the case. There are these ripple effects that because there's less production, like I said, there's longer water ages in the pipelines, which means you might actually have to treat the water to be more stable so that it can withstand longer contact times in pipelines and be able to withstand warmer temperatures since there's less flow in homes. So that might actually require more advanced treatment versus less treatment just because there's less production.
So you work primarily in municipal water systems. So you're treating water kind of for a whole city or a whole region, but are there options for treating water more at the source, like right at where it's being used rather than, the entire millions of lines of lead pipe systems that are out there?
Right. Yes. And I think that is certainly a goal of One Water and total water solutions, where you would be tapping into, no pun intended, more localized and on-site water sources such as rainwater catchment systems, where you are trying to use more localized, such as stormwater or rainwater catchment systems that could be treated and distributed more locally. So, of course, that's a great idea, but public health, permitting, regulations, all of that for potable water has not caught up with any of those ideas, and maybe could be viewed as barriers to innovation in that way.
So if I'm a facilities director at a campus and I'm in charge of maintaining water quality within my campus, in some cases, some of the larger campuses actually treat source water. I mean, they may have wells or like Flint be pulling water out of a river or whatever. But a lot of campuses I know are using the local municipal water system. Are there things they can do at a campus scale, when they have dozens to hundreds of buildings, especially just thinking about what's happening inside the pipes of the buildings, not necessarily the system getting the water to the buildings?
Well, I have to say, since my area of expertise isn't so much on how can they reduce water consumption and implement conservation or more sustainable practices, I would like to address it maybe from the opposite side of here are the risks, the public health risks.
Fair enough.
Of potentially taking that approach. Waterborne disease in this country from drinking water, has declined so significantly over the decades that now the number one waterborne disease or water-based pathogen that is affecting the public is Legionella. That is now, it's not so much cholera anymore, Cryptosporidium, Giardia, E. coli, other fecal bacteria. We know how to control and treat and try to prevent them from getting into the water system. Now the number one pathogen that is creating public health outbreaks and killing people is Legionella. And in fact, that was the first public health crisis in Flint. 12 people in Flint died. 12 people died of Legionella during the crisis, versus what we really heard about was lead poisoning or this concern of lead release into the water. But 12 people actually died of Legionella, and the Legionella did not come from it's not an issue that it came from the Flint River. It's due to all the conditions, the loss of chlorine residual, the stagnant water, the change in the chemistry that allowed the Legionella to proliferate at the ends of the systems and cause people to get sick. And this is the number one concern with large campuses and buildings and hospitals. If you are implementing conservation devices that are slowing down the use of water, inadvertently warming the temperature, loss of chlorine, you are creating potential breeding grounds for Legionella. We almost have I guess it's sort of an off-color or maybe not completely politically correct joke about Leeds buildings. We call them Legionella enabling enhancement devices because,
oh, no.
Yeah, I mean, I think we're going to see a rise in Legionella over time as water consumption goes down. This is now Legionella is called an opportunistic pathogen, meaning it doesn't normally infect healthy people. It is present. It is present. But normally healthy people are not sickened by it. But it's a significant problem in hospital settings. It can be a significant problem because where their immune systems are compromised or otherwise more susceptible to disease, that's where we see Legionella illnesses and deaths, not because it's only present in those locations, but because that population is susceptible. So large campuses, buildings, hospitals really need to consider protecting public health in conjunction with conservation sustainability goals.
How do you protect against Legionella other than just flow?
Well, the key things are to maintain a chlorine residual, a disinfectant residual. And in fact, I know the Bullitt Center, which has its own very fascinating and advanced treatment processes, while it recognizes that chlorine is a, it's a undesirable chemical, recognizes the need for there to be a chlorine residual in the pipes there as well. Now, they're not permitted. My understanding is they're not permitted to use their very advanced system. They're still on municipal water, but for their advanced system, they will also carry a chlorine residual to the tap and then have a carbon filter at the tap to remove the chlorine prior to consumption.
I'm going to interrupt the interview here just for a second to explain the Bullitt Center that Melinda is referring to here. This is a building in the Capitol Hill neighborhood of Seattle, not too far from Seattle University. It's a really impressive building, and it was built as part of the Living Building Challenge. I'll be sure to link to the website for the Bullitt Center in the show notes so you can learn more about the project she's talking about.
So maintaining chlorine is hugely important, as well as maintaining high water temperatures in the hot water. I think probably another conservation device is to turn down the temperature of your hot water heaters, right? Keep them, people do that when you have children for anti-scalding, but people also do that because it saves energy to not be heating the water quite as hot. But to prevent and control Legionella, it really has to be above 140 degrees. So again, that just flies in the face of it trying to conserve energy. When we're thinking about one water solutions and trying to look at the whole water cycle, not just be in our silos of, we do source water and we treat source water and do drinking water versus all the wastewater problems. We have to also think about in one water the impacts of conservation and reduced production and output from the treatment plants. That also affects the wastewater side. Less gray water going into our wastewater systems are also constructed for a certain flow, certain volume, and as we flush toilets less and use less water, that's less volume going into those pipes. That means more concentrated solids going into the wastewater treatment plants. And there are, this is all good stuff to be thinking for the future and to be moving towards in the future, but our existing infrastructure, we're sort of in this middle point where I think everything's struggling against these changes.
All right, so before I get a bunch of hate mail, you're not saying we shouldn't do these conservation efforts. You're just saying these are problems we need to be thinking about.
Exactly. These are opportunities for innovation. These are opportunities for bright people to get out there and continue to address so that we can move towards the right solutions.
All right, well, so now that I've stuck a stick in the hornet's nest of sustainability, I'm going to go into a topic that maybe even will draw more ire. So let's talk about bottled water versus tap water. Somebody who just listened to what you just described might say, oh, well, I'm never drinking tap water again. I can die from Legionella. I can get lead poisoning and it's everywhere. Set me straight. Is that what I should be taking away from this conversation?
No, absolutely not. This nation has the best drinking water supplies, in the world. Us and many other nations that do a lot of work, a lot of regulation, a lot of monitoring to make sure that the water is safe to drink. And I am total tap water person. I drink the tap water everywhere I go. I do let the water run and until it's cold coming out of my tap. That's very important. If you just trap that water and use it for watering plants or watering your garden, fill the bathtub and use it over time, however if it just pains you to let it go down the drain, that's totally understandable. But if you let the water run until the water is cold, you've pretty much just eliminated most of the risk posed by any of the service lines or your home plumbing or the materials. You're getting cold water fresh from the water main, and you should be in good shape with a good chlorine residual.
Great. So we're not all going to die. Yeah.
We are not all going to die, and everyone should be drinking their tap water. Bottled water is regulated in a very different manner. People falsely believe that it is more pure. Bottled water is allowed to have 5 micrograms per liter of lead in it. It is allowed to have it. Now, the newer understanding since Flint is that there's no safe level of lead in the blood. 5 micrograms per liter in the water may or may not translate to a certain level in the blood, but certainly bottled water is regulated by the Food and Drug Administration, by the FDA, not by US EPA and the Safe Drinking Water Act. So it's a product. It's a product that is manufactured, delivered. Often it's just tap water that maybe is put through an activated carbon process and then bottled and delivered. And it has its place in terms of portability, but certainly should, in my mind, should not be your source of drinking water.
So could we design a system where we could just treat drinking water at the source? Is that something that's viable, or what are some of the barriers that would keep us from being able to do that?
When you mean at the tap?
Yeah, so say I'm at a campus and I'm thinking about uses of water beyond just drinking. Well, and I guess that brings up another conversation about, what's the difference between drinking and cooking with water versus taking a shower in it or using it in your toilets or to wash your hands? Are there nuances there I need to think about?
Yes, and I think that in terms of conservation sustainability, it is, it's obviously ridiculous that we flush our toilets with purified drinking water. But clearly cooking and bathing and drinking, all potable uses where it can be inhaled or absorbed through the skin, we want to make sure that water is all treated to the highest standards. But certainly flushing toilets and watering our lawns, and that's where many utilities are working towards building infrastructure, purple pipe, reuse water, where water can be treated to a lower standard and then distributed for non-potable uses. Certainly in California, and utilities all over the nation are working the bright water. So we have that here too, where we're trying to take reuse water that can be used for non-potable purposes in our homes. And then parts of the nation are even looking at direct potable reuse, which is makes people cringe sometimes, but that is taking wastewater and treating it to drinking water standards, where you would direct potable reuse. So we're moving in those directions in some places. But to your question about treating right at the point of use, well, in Flint, Michigan, every home right now has a water filter, because until we can demonstrate that lead is completely stabilized, the recommendation has been to filter at the point of use, so at your kitchen tap. But for buildings and campuses, it gets a little tricky, because under the Safe Drinking Water Act, any facility that serves 25 or more people 60 days a year is considered a public water system if they put some treatment on. So if you're just purchasing City of Seattle water, you're University of Washington, you're just purchasing Seattle water, of course you're serving many more than 25 people 6 days a year, but it's just passed through your system. You are not a public water system. But as soon as you alter that chemistry in any way, whether it's adding a little more chlorine, putting it through UV disinfection, even a filtration device, you are then considered a public water system and have to comply with all elements of the Safe Drinking Water Act.
Wow. So even if it was an elementary school or even a large apartment complex, you would run into that limit. Is that a good thing or a bad thing, or what should we think about that?
I think it depends on which side of of the equation you're sitting on. I think in general, it's probably a good thing that there are there's some standards in place that require folks to consider. You can't just be changing the water chemistry and serving it to the public without approval and without certified operators and without Department of Health approving and ensuring that your practices are up to speed. There's so much opportunity you could overfeed a chemical and poison people. You could connect it improperly and create a cross connection where non-potable water can get into the system and under certain pressure events. There's so many opportunities for truly creating an on-site, on-premise poisoning event that it's very important that people are aware of and not just casually installing these treatment systems. Now, many public schools have their own private wells, and there already are public water systems, and they know about these things. But with issues like lead and copper, the lead and copper rule, where schools and other locations have had to install on-site corrosion control treatment to prevent lead and copper leaching into the water, they have had to become public water systems.
Well, so I can totally understand that we want to prevent poisoning events. On the flip side, I suppose this is a pretty big barrier for people trying alternative approaches. I mean, right now it sounds like our entire system's set up for large-scale municipal water systems, and all the safety rules and regulations are kind of designed around that concept. But as we move into ways we can use less water as a society, which is sort of a necessity. I mean, it's going to have to happen, especially in areas like California or Arizona. We're going to have to figure this out. And
you're absolutely right that this is where the industry needs to catch up with the reality of our stressed water resources and the need for more localized use and distribution needs to catch up with the regulatory structure and our actual physical infrastructure that's out there, and there's going to be pressures coming from all directions.
Melinda, as we wrap up this episode, perhaps you can give our listeners just a few key takeaways that they can think through as they're navigating some of these issues that you've raised today.
So I guess one of the key takeaway messages is that the longer the water sits in the pipes and the warmer it gets, on the cold water side, the longer it sits there, the less you use, and the warmer it gets, the more time it has, the more reactions it has with all the metals on the pipe, with the bacteria inside the pipe, and the more that leaches into the water and can come out your tap. So while a point of use filter could address a lot of that, then we're relying on homeowners and untrained professionals to properly change out those filters and dispose of them to ensure that public health is protected. If they are left in place, whether it's the tabletop pitcher type filters or the filters that go right on your tap, those are sitting at room temperature. They are breeding grounds for bacteria, and they are accumulating metals. And if they are not properly treated and replaced and then disposed of, it's another product that now needs to be produced and disposed of. We can do more damage to our public health and safety than maybe just drinking the tap water and letting it flow in the first place. This is a really fascinating time to be to be an engineer in the drinking water industry, and to be thinking about our aging infrastructure. There's hundreds of billions of dollars of improvements that would need to be spent to upgrade our pipelines, our treatment facilities, our pump stations, our storage facilities, and it's really a fascinating time and a great opportunity for engineers and other broad-thinking people to get involved and help redesign, reconstruct, and as we're moving into newer facilities and newer infrastructure, rethink how can we better balance the need for safe, reliable, pressurized, treated water, but with lower consumption, lower chemical use, more conservation-oriented, coming at more localized and point-of-use sources.
It's really interesting to hear the many parallels between what you're talking about with water systems and what I see in energy systems as well. And in both cases, it seems like we can no longer just make incremental changes to these systems, but we really need a holistic rethinking of how they're set up in the first place. I'll be really interested to catch up with you again in another 6 months or a year and see how things are turning out in Flint or some of the other cities where you're working around the country. But before I let you go, are there any organizations or materials that you could recommend to our listeners, especially on the solution side of things?
Yes, definitely. The American Water Works Association, that's our industry organization nationwide. There's lots of information for free on their website. You could look up Total Water Solutions is one sort of group of packages and publications, and another one is the One Water concept, where they're really trying to look at opportunities to look at the whole water cycle and meet all these sometimes competing but all equally important objectives.
Great. Well, Melinda, it was really great to have you on the show today. I'll be sure to get those links to those organizations in the show notes. And thanks again for coming on the show.
Thank you, Dave, for inviting me to speak with you. It's been really interesting, and I've learned a lot, and it caused me to think about things in a new way, too.
That's it for this podcast. As always, you can find links in the show notes on our website at campusenergypodcast.com. We love your feedback and show ideas. You can drop us a line on Twitter. We are at Energy Podcast, or send us an email to feedback@campusenergypodcast.com. If you like the show, please take a moment to leave us a comment on your favorite podcast catcher such as iTunes or Stitcher. This really helps us get the word out about the show. Thanks for listening.